that's not much of a, compared to a house price. What this is telling me, and I wish I could write this down here, but what that p-value is telling me is basically, kind of sort of, it's telling me there's a 99% chance that the true vinyl coefficient might be 0. So the true effect of vinyl on house prices might be 0. Remember, I need that p-value to be low to say that effect is significant. Since that p-value is over 99%, that tells me that vinyl, even though it looks like vinyl lowers the price of the house, that is not a significant impact on the price of the house. And the reason I mention that, and this is a question that you guys have kind of indirectly been asking me, could we put 2 dummy variables in the model? And the answer is yes, we can. Let's say we wanted to include school district and vinyl. How would we do that? All right, that was not supposed to be met with just utter silence.
Oh.
Go to stat, regression, fit regression model. So stat, regression, fit model. Our response is still going to be price. Our predictors, we're still going to have square footage and vinyl, but we also want to include school district. So how do we do that? Just double click on school district, or good school, sorry. So double click on good school there. So that's going to give me a dummy variable, or I'm sorry, regression equation that has 2 dummy variables in it. We've got we've got square footage still. We also have vinyl, and we have good school. Now notice what happened to the coefficient on square footage. Do y'all remember what it was in that last regression? It was like 218. It's now 222. That's a good sign. If the regression equation or coefficient stays about the same, that's good. You don't want it to change hugely when you put in a new variable. Notice what happened to the vinyl coefficient though. In the last model, the vinyl coefficient was negative 106. Now it's positive 98. Remember what we said about vinyl? There's a good chance it could be 0. Well, look at the p-value on vinyl. The p-value is still 0.9. It's still saying that's not significant. So I'm not surprised it showed up positive this time, negative. There is no significant relationship with vinyl and price. So it's not surprising to me that that changed from like a negative to a positive. How about the school district variable? Is that significant at 5%?
Yeah.
Yeah. And why are you saying that? Because the p-value 0.042 is less than 0.05. So I've got 2 dummies in my model now. Square footage, significant. Vinyl,
Not so much.
not significant. Good school,
Yes.
it is significant. All right, let me throw this one out there at you, and think before you groan and say you don't know. How would I interpret the 22,128 on good school?
Accounting for vinyl and square footage.
All right, stop right there, Kim. Are you accounting for the size of the house and whether it has vinyl siding?
If the house is in good school district,
If the house is in the good school district,
The price
Prices
of the
of
house
the
price
will
goes
go
up
up.
22,128. How would we interpret the vinyl coefficient?
Accounting for square foot in a good school district, the price will go up $98 a square foot, or 98, I don't know.
$98 if the house is vinyl.
$98 if the house
Thank
has
you.
vinyl siding. How about the square footage? I'll help. Already accounting for whether it has vinyl siding and the school district, each additional square foot raises the price to 22.2. We interpret these things the same way. You have to hold everything else constant. The only thing that's really different is now these dummy variables are not as vinyl goes up one. It's now if the house has vinyl, then the price is going to be $98 higher. $98 higher compared to
Being in a bad
The
school
others.
district.
not the bad school district. This is the siding variable.
Having wood or brick.
Having wood or brick. That's that coefficient. Well, I debated whether to do this. but I decided what the heck. That $98 is compared to wood or brick. Do you think maybe there's a difference in wood and brick?
Yes.
So could we include wood or brick in this as well?
No.
Didn't tell us, bless your heart.
No. Now, that's the point I was getting at. When I tried to put good school and bad school, many tab bless my heart. Why did it bless my heart? Because I only had
Same
two
category?
categories, and I tried to put in two dummies. But in terms of citing, how many categories do I have?
3.
I've got 3 categories. Since I have 3 categories for citing, I can put in 2 dummies. I can put in a vinyl and brick, or a vinyl and wood, or
Well, you
brick.
couldn't
I
put
couldn't
3,
put all
right?
3. If I tried putting all 3, many tab would bless my heart again. But if I've got 3 categories, I can put in 2 dummies. So y'all rerun this regression. Same variables, but include not only vinyl, include brick as well. It's not gonna bless your heart, I promise you. I don't think so. No, I didn't say include vinyl, wood, and brick.
Oh,
I said include vinyl and brick. You can't
Yeah.
include all 3, but you can include 2.
Square footage and brick are
Square
significant.
footage, go ahead and include square footage, vinyl, good school, and brick. So once we do that, again, I'm gonna do the same thing, I'm just gonna go ahead and put brick in there as well.
And good school.
So, we get ourselves a regression equation. Did y'all get this equation? All right. Notice the coefficient on square footage about the same as it was before, 220 something. That's a good sign again. You don't want your coefficients to change dramatically just because you put in something else. The coefficient on vinyl changed by a whole lot. Well, that's not really surprising to me because vinyl was being compared to 2 groups and we've now separated. So I'm not surprised that the vinyl coefficient changed a lot. How about the good school district? Did it change much? What was it before? It was 20 something thousand, it's still 20 something
Up a
thousand.
little bit.
Yeah, it's a little higher now maybe, but it's in the same ballpark. And then we also have this brick coefficient here. So, fingers crossed, how would I interpret that brick coefficient?
Already accounting for square footage, vinyl, and good schools. For if the house is brick, it's an additional $32,547.
Exactly, if the house is brick, it's gonna be $32,547 more compared to,
vinyl and.
not vinyl, vinyl's already in the model.
Compared to
Wood.
Wood.
Compared to wood, it's always compared to the category left out. It's no longer vinyl and wood because I've got vinyl in the model. This 32,547 is compared to the other category, the one that's left out. You always interpret dummy variables in relation to the category that you've left out. And I don't know, I told you I'm ailing tonight, so I'm kind of running out of steam now. But you should be able from this to take a house, 2,800 square feet, with brick siding in the bad school district. Think about how we would predict the price of that house. What would I plug in for square feet? 2,800. What would I plug in for vinyl? 0. Because why is 0 there?
Anything but vinyl is in.
Okay, and what did I say this house had on it?
brick.
Brick. Since this house has brick, I'm going to plug in a 0 for vinyl.
And a 1.
I also said it was in the bad school district, right? So what would I plug in for good school there? 0. So this term and this term would just go away. What would I plug in for brick?
1.
1. So I would take this plus this times 2,800. This would go away and this would go away. And then I would add 32,547 because the house has brick. What if that same house had wood?
You put 0.
It'd be 0 for vinyl, 0 for good school, and 0 for brick. If it was wood, You basically just look at your regression equation, plug in ones if it has that, plug in zeros if it doesn't, and then multiply and add. So, final question, probably not, but maybe. Are any of these individual coefficients significant at the 95% confidence level?
Square footage and good
Square footage
school?
is with its 0, 0, 0. How about vinyl?
No.
Still not. How about good school?
Yes.
Yes. How about brick?
Yes.
Yes. So brick is significant, good school is significant, square footage is significant, vinyl is not. All right, so what I have for you guys to continue playing with here, if you go back to Blackboard and you look in that data sets folder, which is where you probably are anyway in Blackboard, if you look in that data sets folder and you scroll all the way down to the bottom, you've got the house prices model there. And I did attach a PDF here. If you open that PDF, I ran a few regressions and marked them up for you. Essentially told you what numbers were important and what the numbers mean and kind of how to interpret them and stuff like that. Scroll on down a little bit, and I think I even did some predicting for you. Yeah, if we wanted to predict the price of a 2,500 square foot house with 180 feet. Anyway, I'll walk you through this and show you how to do that. So, you got that. The next page has one with square footage and letters in it. The next page has one with square footage setback in bathrooms. Oh, we didn't talk about the multicollinearity problem tonight. Yeah, remember when we had square footage and bathrooms both in our model? It caused a problem. The problem was square footage and bathrooms were too closely related. Minitab couldn't separate those two, basically. That's called multicollinearity. And at the bottom here, I was going to talk about multicollinearity and how we can detect it, but I'm not up to it tonight, guys. We'll talk about that next class. But you should be able to go through this model